running and improving and maintaining your site in the real world. So throughout the day, we've been talking about, scaffolding new projects, iterating on those projects, building those projects. Now we're going to start deploying those projects a little bit more, scaling them, managing them, and all that fun stuff that happens after you've kind of wrapped up some of your development and you got to start working on some more stuff. So scaling, adapting to change and iterations, and finally managing your environments. So let's get real. Let's start talking about scale. So right now, who here has to wear the hat of kind of managing some servers that their applications sit on? A little bit? Okay. You're very lucky, because that means there's somebody else in your organization who has that very tedious job. So your site load varies over time. Your site being, a website, a web application, a program, anything that you're managing for the most part. The reality is, you're generally not going to have consistent load 24/7. Nothing's that easy. So you need to be able to adapt to that, and you need to do that smoothly. It shouldn't be, a big time suck for you, nor should it actually cause interruptions for your users. So how do you deal with the various load profiles that you're going to see in the production type environment? So there's 4 that we generally talk about when we talk about cloud computing and managing of your servers. 1, this kind of idea of batch processing. So, we've all at one point in time worked on a piece of code that was run daily, weekly, monthly, whatever, to do a report generation or to do a big batch job. So in this type of scenario, we need to get some servers up and running, run our job, and then nothing happens. And if these servers are on-premise or maybe in a co-location environment, that means they're generally sitting idle for the majority of the time, not doing anything, but they're actually costing you money. What about predictable scaling requirements? So maybe you have a seasonal website. You sell Christmas ornaments or back-to-school supplies, or you run seasonal promotions where you know that there's going to be fairly predictable increases in your traffic, or you're running a big ad campaign. Well, you would either have to manually adjust for that in terms of how much hardware and infrastructure you're running, and then what would you do with that after, especially if you're, again, on-premise or in a co-location type environment. The bottom left graph I usually refer to as the startup graph. This is a fairly common graph we see when startups predict their general growth. Everyone seems to have this nice growth pattern. But should you be lucky enough to see this type of just kind of beautiful, consistent growth, well, you need to decide how are you going to handle that? Are you going to buy enough hardware up front or lease enough hardware up front to kind of handle your future predicted growth? Or are you able to adapt and scale as needed? And lastly, the one that we probably see the most of and the one that probably keeps most DevOps or IT folks up at night is unpredictable requirements for your infrastructure, right? This can be positive. It could be, maybe you got mentioned on a major news site or news source and that bumped up some traffic and you didn't expect that to happen. It can be negative in the terms of distributed denial of service attacks. It could be, for whatever reason, your users stopped coming to your site, but then, you added a new cool feature and they came back. So you're going to have this flow of unpredictable scale requirements. So what are some of the things you can do to handle these 4 different load profiles? Well, generally under the blanket of, use the cloud, and specifically use Windows Azure, and we're going to show you how you can do that. So one of the ways to kind of increase the performance you're going to get per server that you're dealing with is to preserve your server's bandwidth. And this isn't just in terms of the pipeline going to your server, how much bandwidth is coming in and out of it. It's just also how much requests it's having to manage for all the different kind of static files that your server is serving. So one of the things you can do is actually kind of offload that onto Windows Azure Blob Storage. So our blob storage is a fantastic way for you to kind of take all of your static content. This could be, CSS files, JavaScript files, image files. It could be media files, video and audio, and move it from your server, your website or your web app, over onto storage. And there's a number of reasons why you want to do this. One is it actually alleviates the bandwidth from your server and puts it onto us. 2, it actually gives you a central area for managing your static content, and this is beneficial for 2 reasons. 1, if you scale your website out, you're still only serving static content from one location. So you could scale your web front end to n number of instances, but you only have one location where you're worried about managing your static content, and that's where your users are pulling from. And 2, this is the step in the right direction for getting your content out on a CDN, or content distribution network. Why this is beneficial is because then the CDN can pull from this one location and move that static content to edge nodes so that the content's closer to your users. So for example, we have CDN networks across the world, and you can move that content out to various locations so that the users are pulling the static content from servers that's closer, or at least as fast to them. Another thing you can do to kind of increase the performance per server that you're managing to kind of deal with these different types of load profiles is to use caching. So your servers have finite resources. Typically in any cloud environment, you kind of define how much CPU and how much memory you're going to use. And you can use caching to essentially decrease generally the CPU requirements of your server. So you can use ASP.NET Page Output Cache and Windows Azure Caching Service to do this. So let's take the example of a news site. Now, one might think news is always changing, so you wouldn't want to cache the output of that. But in reality, what you can do is say, even if the time to live of that cache was a minute, well, you might save 100 or 1,000 requests, which are otherwise compiling that information, hitting the database, and sending it back to the client. So if you cached it and kept it live for even a minute, that could be a huge, huge decrease in the amount of CPU that your server's using. And you can also use some of the stuff we've been talking about, like single-page applications and JSON requests and web APIs, to have just a small section for kind of breaking news or live updates. So again, you're still getting the best customer experience, but you're maximizing the resources that your servers are using. Now, with manual scale, you basically decide at some point, I need more resources. You would need to know that you need more resources, and that's a whole other conversation that we'll have in a moment. But how would you actually manage that? There's really only two ways to go about this. You can add more servers, or horizontal scaling, so you scale out. And that would require that your code actually handles that. And basically everything we've been talking about today is essentially in the world of being able to write applications that support this type of out scale. Or you can do vertical scaling and moving up in terms of size of the server that you're using. So from a small server that maybe has 1 or 2 processors and a little bit of RAM, all the way up to a massive server with 8 cores and 56 gigs of RAM. So your job is to really decide how you're going to scale. And so this is just an example of how you would do this within Windows Azure. Up at the top, you'll see instance size. Let's see if we can get this working here. So we can see that you can change. Nope, that's not going to do it. Nope. I haven't quite figured it out on this one.
Do like this to zoom.
Hey, I see. There we go. Yeah. Learning something new every day. So here we go. We can change the instance size from a small single core, and we can change that at any time we want, whether it's on a website, a web app, or a virtual machine on Windows Azure, and we can change the instance size to any number of sizes that we support. And also we can change the instance count. So this is actually one of the great. It's kind of hard to see. Let me just come out of here. The instance count. What I particularly like about Windows Azure is the fact that a lot of the services allow me to just go in and move a slider bar along, and that'll actually change the number of instances we're using. So I can decide, my website actually needs 2 instances or 3 instances, or my web API front end needs 5 instances, and if I move it to 5, Windows Azure will go and provision that for you, but also go and provision a load balancer for you and start load balancing those requests on your behalf. You don't even have to worry about that. That's fantastic. But better than you doing this is letting us do it for you. So auto scale. Now, when you have manual scale, right, you need to have some reporting, you need to be monitoring your metrics, you need to know that you need to know to scale. And you should know this before your users figure it out, because they're having a degraded experience on your site or using your API. And that's not easy. And that generally keeps DevOps folks or IT folks up at night. So what you can do is you can use Windows Azure Autoscale. And what Windows Azure Autoscale allows you to do is define one of 2 ways to manage your scale. One is a previously defined schedule. So say you're running a transit app. And so that means, generally speaking, in the morning and again in the evening, you're going to see a huge spike in your usage. But throughout the day, kind of peters off probably a little bit, right? So what you can say is, all right, in the morning, I want 4 servers. In the afternoon, I want 2 servers. And then again in the evening, I want 4 servers again. And that allows you to save money because you're only using as much as you need at that point. So that's good, and it's good if you know what you know. But if you don't know what you need, then you can actually use the auto scale by metric. So in this case, right now we're supporting the CPU metric. It allows you to define a range. So we monitor the CPU of your servers, and you say, when it's within this range for too long, go ahead and scale up, and you define just how many instances you want. We'll keep an eye on things, and when the traffic dies down again, if it dies down again, we'll scale you back down again. So this is great because now you don't have to worry about it. We'll take care of it for you. So let's see how that works. And by doing a quick demo once I log back into my machine here. Okay. So, scaling. As I mentioned, taking the bandwidth requirements off of your server and moving onto our storage for your static content, very, very easy to do. I'm going to show you how to do that. This demo typically takes a little bit longer to set up storage, so I'm going to do the old Food Network approach and show you some previously baked goodness. So I'm going to head over into, scroll down here. Where am I? Storage, wow. Okay, there we go. Sorry, I was blinded for a moment. So I'm in the storage section now of Windows Azure through my portal here. And what I did earlier today is I went new, and then I went quick create, and I created myself a new storage account. And I said, yes, I do want geo redundancy, which also includes local redundancy. What that means is local redundancy gives me triple redundancy on the local storage, and geo redundancy means it takes that same content, moves it to a different data center, so that should there ever be a massive catastrophe, your data is still okay. So I went ahead and created this Geek Quiz storage account here. And then from there, I configured a container. Now think of a container as like a root folder that you can apply permissions to and you can access. So I created one called images, and I made it a public container, which means it's accessible over HTTP and HTTPS. Now, to get my content over there, what I did was I selected my storage account, I selected Manage Access Keys, and using my storage account name and my access key, I launched one of the number of different storage explorers that are out there on the market right now. There's a bunch of great free ones. I think there's even some commercial ones. I myself like to use Cloudberry Explorer for Azure Blob Storage. It's one of those nice free ones. Really easy to use. You just go File, Azure Blob Storage Accounts. You can add a new account, add in that display name, and the account and the shared key, which I've obviously already done. So you can see here I said, go into my Geek Quiz storage, open my images container, and all I did was drag and drop my static content. So I just had to go into my folder here, grab my assets, and if I hadn't already done it, I can just drag it in here, and sure, let's go ahead and upload it and replace it. And it's going to go ahead and upload that. And what that does now is it moves it into my storage account, into that container, and now it's accessible over HTTP. So I can start using this to pull up my, my content rather than my actual web server. So we'll just go and grab this URL. And you can see that the image came up, and it's being pulled from geekquizstorage.blob.core.windows.net/images. So that's easy enough. Now, how do you actually change your project to do that? So there's a really cool little feature in the web.config that uses IIS rules here. So let me just pull up my web.config file. I'll zoom in here. And I'm using the system web server rewrite section of the web config. Anybody ever actually use this module before, the rewrite module? Oh, a few of you. Great. Fantastic. Was it for this type of purpose, or were you using it for, URL mapping from existing applications to new applications? I'm sorry? Oh, culture. Yeah, that's a great example. Yeah. Anyone else? About the same? Sure. All right. Well, in this case, what we're going to do is we're going to create a rule to actually redirect our images. And what we're saying is that we want to match all incoming requests that match img/, and then we're going to capture everything after that. And the action is to redirect that request to this blob storage. Now, in this case, it's to an existing server called geekquizstorage.blob.core.windows.net/images. And then this is just the syntax for saying insert what you've captured from the rule. So now, if I run this application, you're going to notice a few things. The image came up, as one would expect. But if I inspect the element, the HTML code remains source/image/logo-big.png. So what's actually going on here? We'll take a look at the network trace, and I'll zoom in and show you what's going on. So when we make a request for /image/logo, it's actually returning a 301, which is a redirect. That 301 tells the browser to go pull the same content from this URL here. So that's just a really easy way to take all of your static content, for example, everything in the images folder, your JavaScript folder, or maybe have video media, and move it off of your server. Any questions on that? Pretty straightforward. Think this is something useful you might be able to actually utilize? Great. Okay. So the next demo that I want to do on scaling here is actually on auto-scaling. So I've already kind of previously went and published this app, the Geek Quiz app, onto my Windows Azure websites here. So Geek Quiz Scale Demo, just to save a bit of time. Now if I open that up, you're going to see some options up here. We've got dashboard, monitoring, configuration, and we got this preview for scale. So right now, auto-scale is in preview. You can enable this in your account by going into your account settings and under preview, enabling this preview. One thing to note is this only works in standard mode, so you'll have to move your website from free or from shared up into standard. And now what you can do is you can either set up scheduled times, as I was talking about, so I can just go in here and say, use one of my pre-existing defined scheduled times, or I can create a new scheduled time. And that's just going to bring up this wizard here where I can select what time. Do I want to scale differently at day at night? Do I want to scale differently on weekdays or weekends? And then I create my rules. Fairly simple, works if it's one of those known scenarios. This is actually great in this concept we talk about, like dev test. So if your company is leveraging Windows Azure for your dev infrastructure, your test infrastructure, well then during the day, during your core working hours, you might want to scale that up. But maybe at night, when hopefully you're not working, they can scale that back down and actually save some money. So now what we're going to do is we're actually going to go ahead and enable auto scale. And we're going to do that by saying scale by metric, choose CPU. And then now what we're going to do is we're going to choose how many instances do we want to scale up to. So you can scale between, say 1 and 10 instances. I'm going to say I only want to go up to 3 instances so I don't get charged too much. And you choose your target CPU range. So what it says is if for a period of time the CPU range is within between 60 and 80%, Windows Azure will go ahead and scale up to the next level for you. And again, it'll keep monitoring, and if any of those services, again, are being hammered too much, it'll scale up to the maximum. So for the purpose of this demo, I'm just going to actually decrease that to make it a little bit easier for me. Yep. Sorry, question?
Is the low end, therefore, when it will throttle down? You got the high end as being 40 and low end 25, I think it says there.
Yeah, and so when it goes below that, we'll scale back down. Yes.
I think you want the max at 30. I don't know what works for you, but
Was that
I would move it lower.
even lower, just to really make sure this happens? You just want to see me get charged for this.
I kind of do.
All right.
So I did this demo on Monday in Oslo, and I hammered the thing, but I was on kind of slower
slower network, okay.
And so I couldn't get it to scale. And then afterwards, during the break, it scaled up, but it took a little time. So
Now, there's this whole other section for how to manage the scale of your database. We're not going to get into that right now. This is specifically about scaling websites, but we can have a whole other conversation about that. So I'm going to go ahead and save that. And while that's happening, I'm going to pull up a copy here of a stress test application that we've put together. Now, I'm actually going to show you how to build this yourself, but because this takes a little bit of time, I just want to go ahead and get this running. So what I'm going to do is browse to my website so I can capture the URL here. And I'm going to go into my web test, and I'm going to change the property of this rule to point to my site. I can do that here in the properties window. So Geek Quiz Scale Demo, save. And now, if I, in my Solutions Explorer, move over to the load test. Now the load test uses my web test, and it's actually going to create a significant load. Again, just bear with me while this is running, and I'll show you actually how to do this yourself. So I'm going to start running that test. And so this is really handy. You can do this ad hoc. You can make this part of your regression or integration build process. You can have a daily summary or weekly summary of your server performance by using these. It's very fantastic. Definitely worth, and there's so many features in here that we're not even going to get into. So definitely check out some more of this. Okay, so while that's going on, let me just minimize everything here and start a new project. So we're going to just simply create a new project here. And instead of web, we're going to move down to test. And we're going to choose web performance and load test. And just hit OK. So that's going to start up that project for us. So by default, since I said a web and performance test, it's already kind of started a web test for me. And so now in that web test, we're going to add a request to it. So this is kind of how it works. You start with the type of test you want to do, so in this case a web test, and you have a couple of options. I want to add a request, a web service request, a transaction, loops, conditions. So it's quite complex what you can do with this. And the goal is that you're trying to actually build and mimic actual user usage of your site and scale that out so you can test your performance. But we're going to do a simplified version of it. So when I add a web request, it defaults to localhost. So we'll just bring up properties and change that to our site. Scale that out. So now we see we have a web test and it's making a single request to our home page. A little hard to see that. So that's not really all that interesting. It's not actually going to generate all that much load. So we're going to add a loop. And we're going to add a for loop. And in that for loop, what we're going to say is we're going to terminate after 1,000 requests. We want to increment by 1. Each, or initial value is 0. We want to increment by 1. And we want to set the context parameter name to type iterator. And I will check my notes and make sure that I did everything right, and I believe I have. You can then choose what URL you want to use first versus what URL you want to use last. Now, we only have one, but if you added many requests to this web test, you can actually start configuring the actual path the user is going to take. So now if I loop back, or zoom back in, we can see that we're doing a loop, starting from 0, incrementing by 1, while iterator is less than 1,000. So that's going to generate some pretty good load. Basically, what we're saying is this one user is going to make 1,000 requests. Now, how do we scale that out? Well, from here, we'll go and add a load test. So add, and we'll do a load test. And we're just going to follow the wizard here. So don't worry about all that text. It's not terribly important right now. One thing to note here is I'm going to select to not use think times. What think times does is tries to insert some pauses in between the requests to kind of mimic real world scenarios. Users aren't frantically clicking thousands of times a second, so it's going to enter some delays so that your site can actually respond appropriately. We're going to hit next. Let me just zoom out a little bit here, and now we're defining the pattern. So we can choose whether we want constant load or if we want stepped load. So we can have our load kind of increase over time and decrease over time, again, to try to mimic that type of usage. But we're just going to go ahead and hammer our server with, say, 2,500 concurrent users, because why not? Hit next. Let me zoom back out here. Now we're on the mix model. So you're seeing this diagram here. This is basically saying, how do you want the sequence to work for these users? Do you want to have it random? Do you want to have it very specific? Do you want to use user pace? Do you want it based on the number of virtual users? We're just going to go and make it really simple and choose this option down here called based on sequential test order. So it's just going to run through the requests one at a time, very predictable. Now we need to add the tests that we want to do a load on. So I'll hit add and choose that web test that we just configured. Hit OK. Hit next. Now we choose what kind of bandwidth does the user have. Again, we can choose 3G, cable, WAN, SAN. We'll just leave it at LAN. It's all good. Next. And we can choose to actually mimic multiple browser types. So if your code actually responds differently, if you did that thing that I told you not to do, which is to use user agent sniffing, and your code would have different paths as a result. You could choose different browser types. We're just going to choose IE 10 and leave it B. And here's where we can do some really funky stuff. Now, we're not going to do it now for the purposes of this demo, but you can start adding different computers. So my one little laptop here is not going to be able to do tens of thousands of concurrent requests and really hammer that server. But if I had access to a lot of servers, for, say, if I had access to servers in the cloud, I could really scale out this performance test. So we're just going to skip over that. We're going to say duration. You can specify, do you want a warm-up period? You can define how long you want this to run. You can say how many iterations you want to do. You can see, basically, there's a lot of options here for you to really define how you want this to work. We'll just go with the default. And, oh, well, what just happened here is my previous test just quit, and that instance of Visual Studio just took focus. So, yay, the test completed, but I'm going to go back here so I can show you how to finish this. So now we've just created the exact same test scenario that we just ran. Now, if all goes well, if I go back here and I refresh this page, we should see that instance count should have grown. Fingers crossed, pray to the demo gods. I think my computer's still recovering from having to do all that work. Huzzah! We can see that Windows Azure has auto-scaled based off of my requests to 2 instances. And if we come back in about 10 minutes, 5-10 minutes, we should see that that's actually dropped back down to 1 now that we've stopped running those tests. You've finally done it. You've gotten your code into production. Huzzah, happy days. You go take a well-deserved break. But the very next day, you have work to do. There's new features that you need to add, and you need to work on that code base, and it's scary. Also, I don't know who chose this animated GIF. Please never actually do something like this in the real world. Do not use these type of animated GIFs. I'm looking at you, John. But it's true. A lot of enterprises are scared to actually add features and do continuous integration and do continuous deployments at a rapid pace because of this idea that new features equals risk equals you're going to break everything. And the reality is that's not really true, but it happens a lot. And that's mostly our fault as developers. But there's a few things we can do with that. One is test our stuff, obviously. But 2 is to actually use a lot of the new features in Visual Studio and in .NET to make this easier. So one of them is managing your database schema and doing that with Entity Framework. So typically, if you're adding a new feature, that might require you to change your database schema. And that's kind of scary to do. I know back in the day I did it quite poorly by just writing .SQL files that I would then go execute on the live servers because, it's just badass like that, I suppose. Don't do that. That's wrong. Bad idea. Don't do stuff on live servers. Use Entity Framework and use data migrations. So I'm a big fan of this. And if you've used other frameworks, you've seen this model perhaps before with a kind of code-first model and migration files. It's fantastic. Basically what it does is it looks at your models, it looks at what it's previously known as far as migrations, does a delta, and generates the code needed to change your database to the latest migration format. But then it also allows you to revert back should you make a mistake. So I'm going to quickly show you how to do a couple of Entity Framework migrations. And I'm going to do that by pulling up my Geek Quiz project here. So this is the same one we've been using. What I want to do is, because I'm not very good at this, in fact, when I was testing this the other night, I realized just how much I didn't know as far as the questions that were in this database. Kind of made me feel a little dumb. So I'm going to add a hint to my model so that it can help people like me. So first thing I need to do, go into my favorite little spot down here in the Package Manager console, and I'm just going to simply, I'm going to enable migrations. So if you're using an Entity Framework based project, this is a method that's available to you. If I run enable migrations, it's going to give me an error, and I'll explain why. It's going to say that I have 2 contexts that are currently being managed in this project. So which one would I like to enable migrations for? The one I'm interested in is the Geek Quiz trivia context. So I'm just going to copy this very useful message here. It's going to give me the command I need.
Can I talk real quick?
Absolutely.
So the 2 contexts he's talking about, the one is the Geek Quiz context, which is the questions and answers and all that stuff. But the other is the identity model. We haven't dug too deep into that, but that's the actual user login stuff. And that's added by File New Project, ASP.NET. So that's all the stuff for tracking your user information. That's tracked via Entity Framework. Code first. The reason that's important and why I'm interrupting him is because you can get in there and change that. Mm-hmm. So in the past, ASP.NET Identity the way it was persisted out to the database didn't really let you get involved without a lot of pain, and now it's kind of very lightweight and easy to get into. That's why there's two contexts.
Perfect. Thank you very much for that. I'm going to take a note on that myself. All right, so what this is going to do is it's going to tell Entity Framework to analyze my current context and build that initial migration for me. So you see that checking if context targets an existing database. It does. So it's going to tell me code first migrations are now enabled for this project. And if I move over into my Solutions Explorer, I now have a migrations folder. And we see that we have an initial create CS. It's time-stamped. And if I open that up, what you're seeing here is a class that inherits from DB migration, and there's two methods. There's an up method and a down method. So up is when you're deploying it, down is when you're rolling it back. So we can see that it's creating the table, trivia answers, and it's setting the primary key and foreign key and indexes. It's doing the same thing for trivia options and so on and so forth. And down here in the down method, it's actually dropping all that. So removing the foreign keys and removing the tables and indexes. So that's my initial migration. And so now what I can do is I can go into my model. So zoom in here, just open up my models, go into trivia question. So yeah, question.
So that first effort, it represents migration from nothing to something, I take
It
it?
represents the migration from, yeah, exactly, the current point in time.
Which backward presumed a nothing state.
Exactly,
Okay.
exactly. So I recommend, if you're using an existing project that you're wanting to add migrations to and you want to give yourself a bit of a fail-safe, delete the code in the down so that you never actually revert to nothing in your initial migration. And then from that point on, you'll be fine. But if you're starting net new, go ahead and leave it in there because it's actually a great way. I know myself when I do a lot of that early work, I'll just obliterate the existing database and I'll use the down method to do that. I was like, okay, just get all the data out of there. I've been mucking about in it, so I use the down method for that, and then I up it, and then now I've got a new fresh database. So it actually is handy. There are scenarios why you would want to kind of start net new all over again. Exactly. Exactly. I'm about to do that. Okay, so our trivia question model is very simple. It has an ID and it has a title, and then it links to a list of options. So for fellows like myself, I need a hint. So I'm going to add a hint. Not a hunt, a hint. Okay, so I've added this new property, hint. I'm not going to actually go and add hints into the database right now, but what I want to show you is if I go back into my console and I go add migration and I give it a name, added hint to question, and hit enter, it's going to now analyze the current state of my models and compare it to what it previously understood for the migrations by looking at its history, and it's going to go ahead and create a new migration file for me. So if I look at my migrations, I now have my initial, and then I have my added. And we can see in the up method, it's adding a column called into trivia questions called hint, which is of type string, and then the down is it's going to drop that column. So I can go now and zoom out, go back into my management console, and I can run update database. And what update database does is essentially runs through all migrations that haven't currently been applied. So I can actually have a whole queue of migrations required to run, and it's going to go through and figure out the one furthest back in the queue to run and run through them all. So in this case, just going to run through that one and add. Now it's actually going to physically go and add hint to the database schema itself. So we can see it applying and running seed method. So I could have actually added some seed values. I could have actually coded out some default values to insert into the database if I wanted. I didn't, but that's okay. Now what I want to do is show you that it'll actually pick up on changes to attributes as well. So I'm going to go back into my model, and up here on hint, I'm going to zoom in a bit. I am going to add a string length requirement. I'm going to say 140 characters. You should be able to tweet the hint. I'm just going to save that. Then I'm going to go back into my package manager. I'm going to do another add migration. Call this one added length, added max size to hint. Hit enter. And now we'll see that it's created an added max size hint migration. And now instead of adding a column, we're simply altering an existing column. And we're doing that to add the max length of 140 characters. So that just in a really, really small nutshell is how code-first migrations work, based off POCO, plain old C# objects, simply by enabling migrations. The entity framework now is going to monitor those changes, and it'll create the migration files whenever you ask it to. Little suggestion would be when you're doing this, just think of, just like you would a check-in, you want to minimize the number of changes per check-in. I would recommend doing the same thing, the number of changes you make to the schema per migration. They should be very obvious. They should generally just be working on one property or a few properties at a time. What I would not suggest doing is writing like 5 different new models and 45 properties and just putting that all into a single migration. There really should just be a correlation between what you're calling it and what it actually does. Just makes it easier to manage from.
Well, how you apply it to the live database?
So at this point, that's a great question. If I was using web deploy, I think I can show you that in here. If I go into my Solution Explorer and I choose Publish, if I log in, because I think that's what it's about to ask me to do, to my Azure account, apparently twice. I have multiple Azure accounts, and I can't type while signing up.
Keep me signed in, Mike.
Yeah, that might help. Under Settings here, where do they hide the run code first migrations again?
I think it's
Under Profile? I forget where they.
no, it's preview. It's right at the end.
Yeah.
No, it should be under settings.
Database publishing is not supported for this publish method. Oh, because I'm using FTP. No. So, okay, sorry about that.
It's like, what?
This is what happens when you go off script. You just make a mess of things. Okay, so I'm going to change over to web deploy. And now if I go to settings, I can optionally go execute code first migrations, runs on application start. Which means if I publish this now to my Windows Azure server, or you can web deploy it to any IIS instance in your own maybe on-premise or co-location services, it's going to go ahead and execute that. So if you're not using web deploy, if you're using another model, you can invoke this yourself. There's a simple call that you can make to tell it to go and run the existing migration, so you can script this out yourself. You can actually just create your own kind of startup task.
So it will apply all migrations you have in a project?
All migrations that haven't currently been executed. It's going to look at the schema of the server you're deploying to, determine what migrations need to run, and it'll run those.
Okay, so it will automatically check all your migrations and verify whether or not they do exist in the...
Exactly. It uses the ID and timestamp of the existing migrations to determine which are the ones it needs to run in this current point in time. And even if you were to remove some migrations, it knows that, so the next time you run it, it'll run from that point on forward. Yes?
There's a full API that you can also build into your product, your own product, if you want to sort of control everything yourself rather than have it execute at app start. So,
yeah, this is actually a rather large feature. There's a lot to learn about it. In a lot of the different entity framework books and tutorials online, there's sections dedicated to this. It's definitely worth checking out, because depending on your favorite deployment methodology, like if you're using Git or GitHub, which doesn't understand how to do code-first migrations, you'll need to actually use that API and the SDK to have your own kind of startup sequence. So every time that a service starts up, it goes and executes those migrations. I think there's a question over there.
Failure issues. If for whatever reason the scripts aren't valid upon deployment to make the change, or is that inconceivable somehow?
If the scripts aren't...
If you go and deploy it, it gets to the web server, and let's say you have it checked, or the next question is what happens if it's not checked, but you have it checked, it hits there, it's about when the application starts.
Oh, your code will blow up.
And the scripts are not appropriate for the schema for some reason.
Yeah, so what's going to happen is you're actually going to get an error. Entity Framework's going to throw an exception. It's going to say the model does not match the schema of the database.
Is that upon execution or upon deployment?
Upon execution.
So it'll be deployed, and at that point
We'll
you'll
deploy
know.
the code. If you haven't run the migrations, the next request you make will result in a 500 internal server error. I know this because I got the demo wrong last night at about 1 o'clock in the morning. Any other questions?
I just have an interjection real quick.
Yep.
I've learned the hard way. You want to get on migrations early.
Yeah.
So it's very easy in an application to just start monkeying around with the database and stuff, and then actually deploy it to Azure or IIS or wherever. And then after a while, you're like, oh man, I guess I should get on migrations. And it's really kind of painful the longer you wait. It's better to, before deploying, at least as part of your pre-deployment checklist, say, I need to actually turn on migrations now. I'd recommend turning it on pretty much around the file new project time. But if you want to monkey around with your database for a while, get your model right, try something, delete it, that's fine. But just do it before you deploy at least.
Yeah. Anything else? Yeah, going once, going twice. Sold. Moving on. So next, let's talk about deployments, which we started talking about. So thanks. So people sometimes make mistakes. Developers, I think, more so than other people. And what happens is you need to sometimes roll back a deployment that you've made. So, despite your best efforts, and I'm sure we're all very good at doing our unit testing, our integration testing, our regression testing, testing in a pre-production environment, finally pushing it into production, sometimes mistakes still happen. So how can we help with that? Well, actually, it's a really great feature of Windows Azure. For example, in Windows Azure websites, I'm going to show you how we can very easily do a live rollback of your deployment so that you have more time to spend trying to fix it and resolving it without worrying that your users are having a broken experience. So let me switch back to my machine here. And what I'm going to do is I am going to start a new project. How many times have we said that today? I'm going to create a new ASP.NET web application. Sure, save those changes. Why not? That's MVC. Sounds good to me. And while that's happening... Oh, sorry, was there a question? Oh, sorry. All right. So we have our new application. I'm not going to do much to it. I'm just simply going to go ahead and deploy this to Windows Azure. So if this works, that'll be great. I'm going to choose Publish. And I'm going to say Import. And I'm actually going to make a new website. So you'll notice I didn't go to my portal for this. I'm actually doing this within Visual Studio. This is part of the Azure SDK 2.2. It allows me to actually create websites right within Visual Studio into Windows Azure as part of my deployment. So let's call this mgagne demo 005. Yep, perfect, that worked. Subscription, yes, put it on my MSDN subscription. I want this in West US. I don't need a database. No, I don't need a database. Create. Had to think about that one for a second. Actually, you know what? Sorry, I'm actually going to do something different. I'm going to go now into the portal, and I do have a website that I just created. Oops, I wanted to refresh. There we go, mgagne demo. Sorry, let me rewind that a little bit. All right, create a new website on Windows Azure. We'll open it up in the portal because what I want to show you is integrated source control. So I can set up deployment from source control, and that's going to bring me this nice little wizard here where I can choose what type of source control I want. Do I want Visual Studio Online? Do I want local Git, GitHub, Dropbox, Bitbucket, Codeplex, or other external repositories? I'm just going to select local Git repository and hit Next. And what that's going to do is it's actually going to go and create a Git repository for my server. And then this page will refresh with information I need to go ahead and get started using Git as my deployment method. So there's some code here. So what I'm going to do is go back into my new web application. And I'm going to open this in the File Explorer so I have the path to it. I'm just going to copy that out. And then I'm going to launch this down here, which is my little Git bash. I think if I remember correctly, there's a fairly good number of Git users here, so this should be somewhat familiar to you.
I need to zoom in.
Yeah. Just going to paste this in. So I'm just going to basically move into that directory. Did that work? No. Probably need to quote that. Sorry, let me just zoom out so I can see what I'm doing. Edit, paste, that. There we go. So now I'm in the root of my project, and I can see that here. There's my web project, fairly obvious. All right, so for those of you who use Git, fairly simple. We are going to initialize the Git repository by going git init dot. It's going to say initialized empty Git repository. Then I'm going to go git add dot. It's going to add all the files. It's going to throw me some character return line feed warnings. That's the difference between Windows and Unix. Let's just not get into that right now. So now that I've added all my files, I can make a commit. So I can go git commit am initial commit. And what that's going to do is it's actually going to go ahead and create a commit, but this commit's now only on my local repository, right? So I should push that repository somewhere else. Where I'm going to push that to is to Windows Azure. So if I scroll down here, there's a little bit of code, add remote Windows Azure repository to publish your stuff. So there's a nice little handy git command here for adding my remote repository. So I paste that in. And now, for those Git lovers out there, fairly obvious, git push Azure master. Git push, I say where I want it to push. I named this remote thing Azure, and master is the branch that I want to push to. So now it's going to ask me for my deployment credentials. And if we move back into the browser, what should happen is this page should actually refresh once it determines that there's a deployment that it needs to act on. So it detected that there was a deployment. It's now going to take that and actually deploy it to the web server for me. Okay, seriously, how cool is that though, right? It's pretty cool. Okay, so it's now active. I can go, I can browse, and actually see my running website, hopefully. Once it compiles, fantastic. Beautiful, bootstrapped, wonderful HTML5 responsive website. So let's break it. Because we're developers, that's what we do. So I'm going to open CS/HTML, and in this Jumbotron here, I'm simply going to write, oh my God, what have I done? And because I am a developer, let's just go ahead and commit that. We don't need to test. And we'll push that into Azure Master. Again, all I did was commit to my local repository, and now I'm pushing that into Azure. And if we go back to the portal, we should see that it detects, it detects that we have an incoming deployment, and it'll actually do the deployment. It will detect it. Oh, right, passwords. There we go. So it found the latest update. So we can see here it's updating everything. And we have the active deployment called who needs to test. So I'll go in here and I'll hit refresh. Oh my God, what have I done? I've broken our website. Now, at this point, you would typically have to go back and figure out what went wrong, try to fix it, do another deployment to the website. Chances are you're stressed out, you might break more things. The easiest thing you can do at this point is simply go back into the portal, select the previous known good deployment, and simply hit redeploy. Confirm that you indeed want to do this. Go back, and our website will be once again what it should be. Pretty cool, right? You like that? All right, good, good. Yeah, a little round of applause for redeploy.
What about data?
What about data? That's a great question. Again, you're going to have to use the migrations framework APIs to roll that back. Okay? So in this case, when I did a git rollback, it doesn't understand entity framework. So you'll have to actually build that in. If you're using web deploy to roll back, that knows code first migrations. You can run a down command to actually bring that down.
Well, if it's a more complex scenario, let's say my website was running for a week, and we figured it out that something is wrong, but there is a lot of business data which are valid, which I don't want to roll back. So I just want to bring it back to the point when it was functional before deployment, but I don't really want to remove any new records.
So in this scenario, if you're using entity framework, now I might be getting this wrong here, but bear with me. If you're using entity framework, you cannot end up in a scenario where your model differentiates from your schema. So if you've gotten to a point in your deployment where you've changed your schema, your data's been updated, but then you do another deployment that otherwise breaks something, what you want to be able to do is roll back the deployment for that change only, not for the schema. You don't want to have to be able to lose that data, nor do you want to change the model so that you're now out of sync. So this, in this particular scenario, If you did something that changes both the schema and breaks the website, but hasn't incurred new data in the database that you want to save, it's safe to roll back. But if you've done a deployment that changes the schema, that has now added important data that you need to keep, obviously you won't want to roll that back. You'll have to do something else. I actually don't know off the top of my head what you would do in that scenario. Yeah, that's kind of very specific.
It's a hard problem, right?
Yeah.
Yeah.
But
Nice
I mean,
problem to have, right?
Yeah, think of this as the 80-20 rule. Chances are this type of redeploy works for 80%. If you're in that 20%, there's other things you're going to need to do.
Okay.
We can talk about that after.
That's why you get the big bucks.
Exactly. There you go.
And that's
You're
why
going to be
you use
staying
staging.
late that night, basically.
And that's why you use staging environments.
There we go. Yes, exactly. That's what pre-production's for, my friends. All right, let's try to get this back on track. I'm running, I believe. No, I'm about to run a little bit over, but not too bad.
Sorry, I have one more
Yes.
question. Can you roll forward as well? I've never
where
used
am I
Git
lost?
before. I'm over here.
Whoa, hey, how you doing? Okay.
Can you roll forward?
Yeah, so I can go back in if we decided that, you know what, I was wrong. I didn't want to actually do that. I can select another deployment, hit redeploy, and it'll bring that state back in, and it'll just roll it forward, essentially. And if I refresh this enough, you should see it come back to the, oh my God, what have I done? Yeah. And you can do this any part in the chain. So if you've got 25 deployments and you want to go back to deployment number 2, yeah, you can totally do that.
Sorry, so what you're actually doing
Wow,
is...
I'm so not good at figuring out where
Here.
people are. Wow. Hi.
Sorry, so what you are actually doing is actually doing the Git rollback and rolling
Exactly.
forward.
In this case, yes.
Okay. And then, like you said earlier, if you go back, like, say, 3 stages, you have to have some way of keeping the data consistent.
Yeah, data synchronization in that scenario is a whole big bag of hurt. So again, this is why it's also important for small units of change and for testing in a pre-production environment. So as you're making changes to your database schema, test that in a pre-production environment. In fact, we should probably be doing a talk at some point, not today, but maybe we can come back, about using VIP swaps and cloud services to have a pre-production environment and a production environment and switching them. Once you know that your pre-production is solid, you can then take that code and mark it as production and then do another round of testing and updating on this one. It's actually a really fantastic way to ensure that you're seeing what's going to work or what's not going to work before your customers do. So this just kind of recaps what you just saw. And there's a demo that I just did. All right, so the next thing you can do to kind of help out with scaling and with adding features and basically adding to your project is actually leverage the number of services that Windows Azure provides. We're not doing a big deep dive into it today, but suffice it to say there's a lot of stuff in Windows Azure. Identity management, storage, tables for NoSQL, Memcache, web roles, worker roles, Active Directory. I'm forgetting a ton of stuff, and every day they're adding new stuff. And you can leverage these. I call these application building blocks. And you can leverage parts of it, and you can integrate it into your application, or you can connect it. You can connect your infrastructure as a service, or your platform as a service. You can leverage our software as a service. And you can use these to add functionality to your application without having to change a lot of code in your application or otherwise build these yourselves. So take advantage of what's available in Windows Azure services. I highly recommend checking out Windows Azure, checking out the Windows Azure training kit, and learning about the huge amount of services for media, for big data that's available out there for you to utilize to help build your applications. So let's talk about environments now. So running a real site requires multiple environments, as we were just saying. So global availability also requires multiple worldwide deployments. We've been talking about really just doing deployments to a single location. But if you want geo-redundancy, if you want 5 nines uptime, if you want disaster recovery, you're going to need to be able to do this at scale on a number of locations. So you heard us mention this a little bit, the whole concept of dev test environments. Setting up a web server environment can be time-consuming. I don't know about you, but I've worked in enterprises where it's like, hey, I'm working on this new cool little web app. Can you hook me up with an IIS server that I can throw it on so I can demo it? What do you mean that's going to take a month? What do you mean no? So if you leverage the cloud, this makes it a lot easier. So in this case, environment consistency via deployment setups, Windows Azure websites, and VM images. What we're really saying here is you can actually script out, you can pre-configure You can do it through Visual Studio. You can do it through PowerShell. You can do it through the Node command line interface. You can spawn websites and web servers and virtual machines, build out entire infrastructures and networks, including VPNs and connecting multiple systems together, throw up your demo, show it off, and then tear it all down. But you've got it in a format that allows you to rapidly do this. So the idea is to save you cost by paying for only what you're using. So if you've got a big demo, you want to show off to the boss that you wrote something that scales out really cool, go throw it on 10 servers, show the performance, turn it off, cost you a couple of bucks. So much easier than trying to do it on-premise or in a co-location server and basically begging for resources off somebody else. John's talked a lot about MSDN. It's something we definitely recommend for those of you working in the larger companies that can afford an MSDN license, and even smaller companies. I've been part of startups where we bought an MSDN subscription because it just made financial sense. It gives you a 33% discount on virtual machines, 25% discount on reserved websites. It does not require a credit card when you have an MSDN subscription, unless you want to remove the $0 spending limit, and then, yeah, definitely we're going to take a credit card. If you're using Visual Studio Ultimate, you get $150 a month. If you're using Visual Studio Premium, you get $100 a month. And if you're using Professional, you get $50 a month. So, good news, your web app or your application's going big, your company's doing really well, you've got users all over the world. Well, what do? You need global reach. Again, use automated deployment workflows, right? Use the tools that we have, the SDKs, the PowerShell command snippets that are available on WindowsAzure.com to manage deploying out and creating these industry-leading and class-leading deployments across a number of data centers, across a number of instances, using the load balancers, and having this fully automated so that when you do a deployment, it goes worldwide, and then all you had to do is basically run a simple command. For continuous delivery, bugs are an issue. Code gets harder to fix the longer it takes to find out, and deployment becomes risky, error-prone, and otherwise a heavy operation. So what can you do? TFS, ALM, if you haven't heard of these things, check it out. Application Lifecycle Management, Team Foundation Services. Use continuous integration to automate, to build, to run your unit tests, and otherwise run those integration tests. And the reason I highly recommend this, and trust me, I've been there, you're trying to convince others that, yeah, let's make this big investment into all this stuff, and they're like, well, I don't really see the point of it. Every company I've worked with, everybody that, I'm talking from startups to the biggest enterprises, are generally hesitant to integrate this, but are always happy when they do. Because it decreases the risk, it decreases the time to market to add new features, it increases the overall quality of the code, and generally speaking, it increases the user satisfaction of the end product that you're building. And what it allows you as developers to do is actually work on more features and add new cool features because you have the confidence that it's not going to break the system. So you get by this issue where companies are tending to kind of be a little bit scary sometimes, to add anything because it might break something because you don't know what it's going to do. So that's it for my talk. We're actually going to take unless there's any questions, of course. There is a question.
Again, I must have blinked, but I was looking in the Windows Azure, my management screen, trying to find where did you add the Git service, or was that a storage? I missed how you got to the point where you were adding a Git repository.
So
what was the actual product you sort of purchased or added?
No. So all you do is under websites, right? When you've created a website.
So it's a feature of a website. It's not a feature by itself for any kind of.
No. This is specific to website. So when you're on this little part of your website, if you scroll down, now I've already got my integrated source control enabled, but this would say enable integrated source control, and you select, do you want Git, GitHub,
I was looking
CodePlex?
for an actual just repository.
Oh yeah, no. There isn't just like a
Okay.
feature called Git or integrated deployment. No.